Alright guys, so we're going to pick up where we left off from Thursday last week. Still graphing ellipses. How do you do it? What do you do? This is what we're going to look at now. So, what if the ellipse is not centered at 0, 0? Remember the ones that we were doing before looked like this. Nothing with x, nothing with y. Well, now you have something with x, something with y. But that's just as easy as what we did with circles. The center here is going to be 3, negative 1. Okay, opposite of what's with x, opposite of what's with y. Okay, there's your center. You still have the idea of a major and a minor axis. So your major axis is the one with the biggest number underneath. That'll be x, and we'll be going 8 units. So to the right 8 and to the left 8. In the y direction, that's going to be your minor axis because it has a smaller number underneath. And the minor axis will go 4 units. Square root of 16. Again, how do you know that you have an ellipse? Ellipses have plus in the middle, equals 1 over here, and they're going to have at least one of the parts as a fraction. Okay? If there were no bottoms at all and just a plus, that would make it a circle, okay, with a radius of 1. But as soon as you get these fractions going in there, it is definitely an ellipse. All right, so to graph this, let's go ahead and set up a 4-quadrant graph. Okay, so we went ahead and did that. Let's go by 2s to try to make it fit. 6, 8, 10. 2, 4, 6, 8, 10. So again, we went by 2s there. Start by plotting the center, 3, negative 1. So go over 3, that would be between 2 and 4. Down to negative 1 would be between 0 and negative 2. And then again, like I said, we're going to go 8 units in the x direction. So again, we're at 3 here. If we go over 8, we'll actually be at 11. If we go back 8, we'll be at negative 5. Would be right there. And then for our minor axis, y direction, we'll go up 4 units. So we're in the middle here. We could go up 2, 4, or if you're at negative 1 and you add 4, you'd be up here at 3. Go down 4, you'd be at negative 5. And go ahead then and make your ellipse. Okay, so there's really not much new here today. It's just that we're not centered at 0, 0. Now, if you want to find the coordinates of the foci, this is the same work as what we did on Thursday, where you use the formula c squared equals a squared minus b squared. So c squared is going to equal a squared. A squared is always the biggest bottom, 64. Subtract smallest bottom, 16. So 64 minus 16 is going to be... Sorry, I'm thinking that it's 48, but I want to make sure. Yep, I was right. So c squared equals 48. And then we'll square root each side. Now remember, you want to leave these in simplified square root form. So 48 is 16 times 3. So this will be plus or minus 4 square roots of 3. Because again, 48 is 16 times 3. So that's the number that's going to get added and subtracted to the major axis, which is x, the major part of the center, x. So now the way you're going to write your coordinates of your foci are going to be this center number plus this number, and then this center number minus this number. So it's going to look like this. 3 plus 4 square roots of 3, negative 1. That's adding that number to the major part of the center. And then subtract it from the major part of the center. And those are the coordinates of your foci. Okay? Now, last thing I wanted you to find here was the eccentricity. So you find the eccentricity by doing c over a. And we already have c here. I'm just going to call it square root of 48 because you get a decimal for this. Over a is the square root of the largest bottom. The largest bottom is 64. The square root of 64 is 8. So we're going to take and we're going to do square root of 48. This is done on a calculator, of course. And divide it by 8. and that decimal comes out to approximately 0.87. So 0.87 is the eccentricity. Again, that determines the flatness of the ellipse. Okay? Again, a lot of this stuff you're going to do a lot more with when you get into your pre-calc class, your college algebra class. We're just kind of scratching the surface here to get you the introductory information that you need for this. All right, so the second one here, let's go ahead and find the center. The center here, what do you think for x minus 3 and y minus 4? You'd be right to say 3, 4 is your center. Opposite of x, opposite of y. Your major axis on this one is going to be y because it has the biggest number underneath. You'll go 3 units. Your minor axis is going to be x, and we're going to go 2. Square root of 4 is 2. All right, so I'm going to do this graph by ones, even though it's going to go off the graph. Oh well. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, this is going to go off the graph. That's okay. It's easier to count by ones anyways. So plot your center, 1, 2, 3, 1, 2, 3, 4. So 3, 4. And now what you're going to do is you're going to go up 3, 1, 2, 3, and I went off my graph, oh well. Down 1, 2, 3. And then your minor axis, go 2 to the right and 2 to the left. Okay, in the x direction. And then you just go ahead and make your ellipse. Okay, pretty simple to do. Now again, the part that is a little tricky, I think, is finding the foci. We know the formula to do c squared equals a squared minus b squared. A squared is the largest bottom, so c squared equals 9 minus the smaller bottom is b squared, 4. So c squared equals 5. Square root, c equals plus or minus radical 5. That's going to get added and subtracted to the major part of the center. Major part is y, so we're going to be adding and subtracting to the y. So it'll be 3, 4 plus square root of 5. That's adding it to the y. And then 3, 4 minus. You're now subtracting it from the y. And those would be your 2 foci, your 2 focal points. Okay? And then whenever they want you to find the eccentricity, you would just do c over a. Well, we already know the c is the square root of 5 over a. A is the square root of the largest bottom. Largest bottom is 9. Square root of 9 would be 3. So you're going to punch into your calculator square root of 5, hit equals, divide by 3, hit equals, and that comes out to 0.75. So 0.75 is your eccentricity. Okay? All right. I'm going to stop this video here. Make sure you watch the next one, though, because there's a bunch of stuff on completing the square coming up that you definitely want to make sure that you've practiced with me. This is a little bit tougher stuff that's coming up next. So I'm going to pause here, and then we'll go ahead and we'll work on some of the completing the square on the next page. All right. See you in a bit.